Okay, so what I've been talking about is the role that types play in refactoring the internet. So the overarching container for this really has to do with the fact that the internet is, as developers like to say, is being refactored, and so that factorization is really an inexorable move from the centralized control by a few major companies to decentralized applications serving decentralized communities. And blockchain is playing a major role, but the effort is going to be bigger than just blockchain technologies. And there are key technologies such as operational semantics and logical form that are going to generate software services that were never dreamed of by Satoshi's stepchildren. And intriguingly, one of those technologies has been kind of sneaking up on digital culture for a very long time. It's actually been sneaking up on culture for a very long time. Once it was just the purview of philosophers. But, in this century, it's become the stomping grounds of electrical engineers and programmers. But it's going to extend far beyond that. There's consequences for everyone involved in what I would call digital culture. And for those of you who don't know, the picture on the left is Aristotle, and the picture on the right is Jean-Yves Girard. So the conception of logic from Aristotle to Jean-Yves Girard has been massively changed. And it's well worth understanding a little bit about what that change is. An example that I've given a lot for you guys, but I don't know that everyone, first of all, very few people have heard of RChain, but the wider internet hasn't yet grokked this example. And that is that, today code is kind of the dark matter of the internet. So we treat it as a data asset. So we store code as data assets in repositories, but it can't be searched in terms of its intrinsic properties in the same way that we search relational data on the basis of its intrinsic structure. Right. So today we apply metadata to code and we use social techniques. So Bob knows someone named Alice who knows a library that does blah, blah, blah. Right. So that's not a good way to manage such a large and such an important data asset. Now, if you think about it, it turns out, if you do even a little bit of research, over 15 years ago, a group experimented with a system called Hugel, and you can still use it today. The system allows Haskell programmers to search the package system Cabal for programs that type check according to a user-supplied type. So if you just type Hugel in your, or Hugel Haskell, I think there's another Hugel now, but if you type Hugel Haskell in your bar in your browser, you'll pretty quickly get to this page, and you can play around with it. Now, the problem with Hugel is that sort, which takes a list of randomized or unsorted integers and produces a list of a sorted list of integers, has exactly the same type as shuffle, which takes a unrandomized list of integers and mixes them up, shuffles them to a more randomized list of integers, right? So they have exactly the same type, and so So using the type systems of Haskell which is relatively fancy, is going to return both sort and shuffle in the search. So that's not particularly useful at this point. However, the revolution in logic changes this. So it allows us to define much more discriminating types than the kind of types that Hugel is using. And that makes the idea of Hugel much more interesting. So, so the kinds of types that we've discussed here, but the wider community doesn't know about is code that you can search for code that is single-threaded. You can search for code that is multi-threaded. You can search for code that shares secrets. You can search for code that can deadlock. In short, what we can do is search for code on the basis of how it's structured and what it does. And the nice thing is, an immediately short-term application. I mean, I frequently talk about this the other way around. I start with these sort of short-term applications and then try to get people to imagine what happens once you have this capability. But it's possibly easier to understand that once you have this search capability, then searching for multi-threaded code can be turned into a check as to whether the current code, the code being compiled right now, has a race condition. And searching for code that shares secrets can be turned into a check for whether the code currently being compiled has a security error. And these kinds of errors, error checking capabilities, had they been deployed against Solidity code, would have prevented the DAO bug and a bunch of other exceedingly costly mistakes for the Ethereum network. They would never have happened at all. But it also has implications for AI. So basically the idea is that AI can assemble code fragments scattered all over the internet into a larger body of code. So where might it find these code fragments? Well, it can find them on GitHub, but it can also find them in blockchains, right? The code is stored as smart contracts in blockchains. So you use types to guide the search for components that satisfy the user's requirements, where the user's requirements are also expressed as types. So again, to this small group of people, I've expressed these ideas before, but it's important that they go out to a larger community. Of course, again, as I've mentioned before, the revolution isn't limited to code. It's also so broad as to include new approaches to geometric reasoning, which has applications to everything from self-driving cars to protein folding and the development of medicines. In connection to the last point, it applies to dynamical systems such as cell signaling regimes. So here's an example. So there are lots and lots of databases, Swiss Prot, for example, that contain information about both small and large molecules, and in many cases for these boutique databases, they contain information about cell signaling regimes. So you can imagine a query of the form, find all the small molecules. So we're kind of staying to one side of organic chemistry from this database, such that when placed in this concentration in the cell will prevent the cell signaling pathway or behavior from reaching a particular state. So just to unpack this for a minute, reaching a particular state could be a disease state or a state known to be implicated in a diseased behavior for the organism. So what we're saying is find the small molecules that when you give it in dosages that are less than lethal, so in this concentration, prevents the disease. So what we're saying is find a cure. That's what this kind of query turns into. So this changes medicine. And so these are the kinds of things that the algorithms that underlie the operational semantics in logical form make possible. And they make it possible right away. Once you have the algorithms implemented, then applying them to these different domains is roughly the same as pressing a button. So what that means is, so now let's think about this. Again, I've continued to emphasize that RChain is like a massive update to our notion of database, right? So if you get the architecture right, then you can store lots and lots of data on chain. And why would you want to do that? Well, I've argued, sociologically, that there are certain things that you want the community to control whether or not it's live, whether or not it's data. And for example, I've argued that I worry very much about RChain and its placing its faith in GitHub. And maybe that sounded crazy. But last year, GitHub disenfranchised a bunch of developers who were in certain nation states. Right? Once Microsoft bought GitHub, Microsoft was in a position where it had to be in compliance with U.S. law, and so certain nation states were, persona non grata, which meant that GitHub stopped serving developers and code from those nation states. So that's an example of what I was talking about from a sociological perspective. But if we flip it around and look at it from this new query capability perspective, if the database holds geolocation data and it also has these new sort of geometric query capabilities, then suddenly that becomes a serious risk for privacy and autonomy and other kinds of things. Similarly, if the database becomes scalable enough to hold healthcare data and it becomes more useful because of the kinds of queries that I'm talking about, then again, it becomes really important that these capabilities are held by humanity at large and not in the hands of a few. So that's part of the reason why I have worked so hard to make these capabilities open source and a part of a decentralized application. So again, I just want to emphasize and point out that the main point here is that with the operational semantics in logical form, it's not just that we get these wonderful type systems, is that right on their heels we get these query mechanisms, and those query mechanisms dramatically extend the utility of RChain. Right? Because now RChain can be used to query data in a way that we have never queried data before. That was simply impossible before. So that's a direct sort of value add to RChain that these types offer, that the operational semantics offers, and one of the reasons why it's I mean, in addition to what it provides for Rolang in terms of safety, it's one of the reasons to fund the research on the operational semantics. So that's roughly it. I mean, the remainder are slides that you've seen before in terms of making a little bit more concrete, how to see these types as queries and things like that. But let me stop there and see if there's any questions or comments about this this content, because I think it it it's important in terms of our outreach to the wider world.
Yeah, I think this is a great explanation. It helps to provide even more clarity to a lot of the concepts you've been presenting. So I'm finding it very, very helpful. Thank you.
Cool.
Yeah, for me also, when you talk about programming language as a query, this is like a completely new dimension for programmers to think about. So.
Yes, I agree. It was always there implicitly in programming paradigms like Prologue, where Prologue, the whole programming paradigm was not to tell the computer how to do things, which is what most programming languages do, but rather to say what you were looking for, and then the execution is really program search, right? So that becomes another thing that we can dramatically enrich with this operational semantics and logical form. And that's a, go ahead.
No, I was going to ask, what's your view on why Prologue never took off as much as one would have expected it to?
I think it was a combination of things. One was that it was a relatively different way of thinking. There was a resurgence of interest around 2010, back when people began to understand the importance of data assets and being able to get into, when big data began to take off, Prologue saw a resurgence as a way of looking into big data, and in particular, so logic blocks, I think, for example, built out a data log like offering. So in the late 80s, early 90s, people recognized that you could wed Prologue to a database, and that gave rise to data log and LDL, which were high performance versions of those things. So there was some application and some uptake, but it wasn't mainstream. And then there was a resurgence around 2010 when big data was just being grasped. But in general, in the early days, it was largely because the hardware was not up to the task, and people didn't know how to make it performant. If you want to really maintain the Prologue, the sort of the promised Prologue paradigm without using the cut too much, then you really need to limit the kinds of programs that you write. As soon as you make it a general purpose programming language, then you have to use cut all the time, which means you're telling the computer more how to do things rather than what program you're looking for. So that kind of compromises the ideal. But if you restrict it to data, then it was largely just the hardware at the time was not really up to snuff.
How do you see connection of most of our languages that are function-based with this kind of thinking and this kind of languages with query capabilities?
Well, I mean, in a lot of ways, language integrated query has been facilitated a lot by language models of computation like the lambda calculus, right? So in that regard, language integrated query, or LINQ, and it's knockoffs like Slick and other things. They're well suited to integration with these ideas. But being able to so as long as you're talking about the one use case where you've got a repository over there and you've got a desideratum coming in the form of a query for things of a particular shape, then it fits well with the function-based model. But like I don't know how many people had a chance to see Christian's talk to the MIT. But he sort of talks about the main theorem of the paper that he was working on was essentially that you can take the whole programming model and lift it up from individual terms to collections of terms, right? So that the entire programming model gets lifted to this larger setting of ensembles of terms. And while that doesn't how do I say this? It's a first step, to state it positively. It's a first step towards what we'd like to be able to do and what nature does all the time, which is to program in ensembles, right? So if you think about it, nature throws a bazillion cells at a particular problem and they self-organize, right? It's not really programming each one so much as programming an aggregate of cells that have this ability to self-organize. And so being able to take a programming model and lift it from individual terms to ensembles is the way you want to go, and that starts to bend and twist and morph the programming model considerably. You have to start thinking differently, and it's very different. I think what we've seen is that programming concurrently is also a big difference. The functional model doesn't work so well when programming concurrently. So programmers are going to be forced to change the way they think about programming. And they're going to go kicking and screaming, right? This isn't going to happen easily.
And you mentioned a link, which I'm familiar with from C#, and also the core of the link is another expression language on top of C# that
Yes.
can be observed in C#, and
Yes.
I see the same movement in Scala with reflection.
Yes,
And
that's exactly it.
this,
Yes. Reflection is a fundamental feature. You can't get away from it. That's one of the reasons why Rolang has it.
yeah, and,
Yeah.
and this is somehow you need to be able to express the structure of your language inside the language, right? So that you can do these queries. And
That's correct. That's exactly right. So that's why, or you have to be able to do it from the outside, right? So that's the point of operational semantics and logical form is if you can tell me the description of your programming language, I can construct the type system / query system for you. So that's why it's. It doesn't necessarily need reflection all the time. It doesn't need it at runtime. It only needs it at compile time. So we just need it once at the very beginning. Tell me the structure of your programming language, right? How is your programming language defined? What are legal programs and how do they compute? So if you give me that information, and everyone has to have that information at the beginning or they can't write interpreters or compilers, right? So if you give me that once, then I can generate the query system for you. If you want to be able to generate the query system on the fly, then you need this capability all the time. And that's one of the reasons why we were looking at K framework, right? Is because, you know, K's raison d'etre is the synthesis of an execution model from input about how the language executes. And so they have exactly the input format that we needed. That's why it was so nice to talk to Grigore Rusu last week, because you know, we were arguing that you could calculate a richer type system. So I don't think that they've quite yet grasped what that, you know, the implications yet, because they don't do this for K. And if matching logic were only slightly reconfigured, they could generate these type systems for K in the form of matching logic.
Interesting. And in case of K framework, I was wondering how can we extend existing definition? Like how can we compose multiple languages? Because definition of the syntax and operational semantics, from my understanding, is that it's very difficult to extend. And I mean, one needs to change the initial code. And
they do have a notion of import, which means that you can take theories and combine them. In general, combination of theories requires that the theories themselves enjoy certain properties. And this is why. Go ahead.
I'm wondering specifically if some type is defined. Usually we don't have a way to erase some definition. So if we import something and something is duplicated, we have this problem of ambiguity, or we cannot easily say, or we don't have the same semantics for adding types and removing types. So we can like extend this in both ways. Usually we just add something and
yes, that's correct, and that's why I was talking about distributive laws, right? So when you're adding two theories together, then insisting that the theory that you know, that combination enjoys a distributive law, that will mean that when you add the constructs together, they work well together. And if you don't have those kinds of properties, then you have to isolate constructs that overlap. All right, so you have to say, you know, this version of the construct, this product or this co-product or whatever, you know, comes from this theory, and we're going to keep it separate from that product or that co-product from that theory. So that's you know, you're sort of forced into that from unless the theories play nicely together, right? So you know, taking it down a level, addition plays nicely with multiplication, right? We know how to turn a multiplication into a series of additions, for example. We know how to distribute multiplication over addition. So those two properties, which you could view as two different algebraic theories, play nicely together. And if you don't have that play nicely together thing, then you're you're forced to keep them separate somehow. Arthur, you're always so quiet. Does any of this help you understand what it is we're on about? Why we're doing what we're doing?
Yeah, sure. Yes.
Cool. All right, folks. Well, if there isn't If there aren't any other questions, go ahead.
May I ask you something? I want to ask you for a long time, and it's related to your presentation from years ago. I think it's about the delimited continuation, and you were explaining about the paper of Simon Peyton-Jones.
Yes.
And I didn't understand you from the first time I watched, but later I had a better understanding that you were explaining how you discovered that these basic operations that they are describing in the paper, they didn't say from where they are coming.
That's correct.
And so I'm wondering if these operations are like control and shift. Are they representing what they are representing in rolling? Can you make some connections?
Oh yeah, sure, absolutely. I mean, essentially, what the delimited continuations are doing is they're maintaining a data structure for the where you manage the regions that you can think of it, that the continuations refer to. So in their case, they maintain a stack. So you could easily use Rolang to implement a stack of continuations, right? So if you did a translation of the lambda calculus into Rolang, which is very similar, could be very similarly structured of the lambda calculus into the pi calculus, right? And now, but now you're going to add to the lambda calculus the delimited continuation operations, right? So what you want is you want to be able to manage the regions into which the continuations can return. So that can easily be managed with names, right? I mean, this was a conversation I had with Oleg over a decade ago, is that you can think of the delimiters as being managed with names, right? So you mark off the regions with names, which is basically like implementing the stack structure using Rolang, right? So that's another way to think about it. Hopefully that answers your question.
Yeah, and names, you mean channels? Names
Yeah,
and
exactly.
Channels.
Yeah, names are channels.
Yeah,
That's
yeah. This is very helpful. Yeah.
So I mean, the thing that I was pointing out was they didn't say why a stack, right? I mean, the question is, are there other data structures that might work, like a FIFO queue, or right? You know, do we have to have a stack? What makes the stack interesting? And you know, are there different transactional or control regimes that result, you know, naturally from different data structures? And that's what I would have looked for in, you know, a result that was more explanatory. What is the relationship between the control disciplines and the data structures, right? Because that's, you know, at the end of the day, there's this duality between control disciplines and data structures, right? So if you, I mean, like the simplest way to think about it is, if I've got a data structure like a tree, that implies a certain control discipline for walking the tree, right? I've got a, you know, like I visit this node, like the visitor pattern is one way of thinking about that duality between the control and the data structure. Right? You know, I visit this node and I visit the children of that node, and then there's this question of whether or not, you know, I do it breadth first. I visit, you know, the first layer of children before I descend, or I go all the way down, you know, one particular path until I reach a leaf, and then pop back up and go all the way down, and so on, right? So those there are clear relationships between control regimes and data structures. Now here, what's interesting is they're starting from the control regime, right, which is the delimited continuations, and they infer a particular data structure that makes it easier to implement or model that control regime. And so, the question is there a more general theorem to be had about that relates control to inferred data structure? And they didn't provide that, and I felt that was a missing piece of the puzzle. And it seems like there's an obvious way to relate them in terms of knocking holes in programs, right? Which is a co-algebraic kind of gadget.
Yeah, thanks for this explanation. Yeah.
Sure. All right then. Thanks all for your time and attention, and we'll see some of you in about 20 minutes.
Thanks.
Great. Thank you.
Cheers.
All right.
Bye-bye.